Okay guys, so this is going to be free response set number 5. So in this question it says grass clippings are placed in a bin where they decomposed by this given function right here. It says A of t is measured in pounds and t is measured in days. Okay, so part A, it says find the average rate of change of A of t over the interval from 0 to 30. Okay, so this is going to be a calculator question. So average rate of change is A of 30 minus A of 0 over 30 minus 0. Okay, so we're going to use our table. We're going to plug in our function into y equals. So 6.687 parentheses 0.931 to the x power like that. Probably should put that in parentheses. Okay, so quit, and we're going to go to our table. So 30 and 0. Okay, so you should get 0.78293 minus 6.687 all over 30. And we should get negative 0.1968 pounds per day. Okay. Part 2 says find the value of a prime of 15, use correct units, and explain the meaning of this derivative. Okay, so a prime of 15, we're going to use our math 8. So we do math 8 bars y1 comma x comma, and we're evaluating at 15, so we put 15. Okay, so we get that. So negative 0.1636. This is going to be pounds per day. So if we're interpreting this, it says at t is equal to 15 days, the rate of change of grass clippings is 0.1636 pounds per day. And it's decreasing because it's negative. Okay? So at t is equal to 15 days, the rate of change of grass clippings in the bin is decreasing at a rate of 0.1636 pounds per day. Okay, C. For part C, it says find the time at which the amount of grass clippings in the bin is equal to the average amount of grass clippings in the interval from 0 to 30. Okay, so we want to know where A of t, the amount of grass clippings, is equal to the average rate, the average amount. Okay, so average value, like that. Okay, so the key word here is average. We should know how to do average value now. Now we're going to use our calculator to get the right side of the equation. So we're going to integrate math 9 vars y1 comma x comma 0 comma 30. And then we're going to divide it by 30. So the average amount of clippings is 2.7526. Okay, and I want to know where this is true. So we can either use our intersect with that, or we can use our zeros. I think I used my zeros. So I'm going to subtract the 2.75 over to this side. And I'm going to graph it. Okay, I think my window is probably not going to work out. So let's change our window from 0 to 30. Okay, so we see it crosses right there. So we do second calc, 0. We're going to go above. We're going to go below. So I get t is equal to 12.14. Sorry, t t is equal to 12.4149 days. Okay. And then part D, it says after t is equal to 30, it's better modeled as the equation of a tangent line, a linear approximation. Okay, so it says use the linear approximation at t is equal to 30. So what we need to do is we need to find the derivative, and we need to find our y value. Okay, so I'm going to go back and I'm going to change this because I had that in there in y equals, and I'm going to quit. I'm going to do math 8 vars y1 comma x comma 30. So your slope at 30 is going to be a negative 0.05598. And a of 30 I'm going to get from my table. So 0.78293. And I'm going to use my equation of a tangent line to approximate something. So y minus 0.78293 is equal to negative 0.05598 times x minus 30. Now I want to use this to predict at what time will there be 0.5 pounds of grass. Okay, so I'm going to plug in a 0.5 for y. And I'm going to solve for x, which is going to be my time. Okay, so I'm going to put these two numbers in the calculator, divide, and then add 30. So we're going to do 0.5 minus 0.78293 divided by negative 0.05598, then add 30. So you get 35.054 days. Okay. Next question. Okay. This is important that you pay attention to how to do this question because this is going to be an accumulation question. Okay, it says on a certain workday, unprocessed gravel arrives at a plant by this function from 0 to 8. At the beginning of the workday, you have 500 tons of unprocessed gravel. During the hours of operation, the plant processes the gravel at a rate of 100 tons per hour. So we're going to have an accumulation. Okay, in minus out plus your initial amount. Okay, it says find g prime of 5. Use correct units and interpret the units. So g prime of 5. So we're going to put that function in our calculator. We should be in radians. So we do math 8 vars y1 comma x comma 5. Okay, so you should get negative 24.5875. Okay, so if I took the derivative of this, this is in tons per hour. Okay, so since I took the derivative of it, I'm going to be in tons per hour per hour. So if I'm going to interpret this, this is the rate at which unprocessed gravel arrives at the plant is decreasing at a rate of 24.5875 tons per hour per hour. Okay. Part B, it says find the total amount of unprocessed gravel that arrives at the plant during the hours of operation. So we're going to integrate from 0 to 8 of g of t. Okay, that function up there. We already have that in y1. So we do math 8 vars y1, comma x, comma 0, comma 8. Okay. Oop. Oh, I did derivative. Sorry, math 9 vars y1, comma x, comma 0, comma 8. You should get 825.551. Tons of gravel. Okay. Part C is the amount of unprocessed gravel in the plant increasing or decreasing at t is equal to 5 hours. Show the work that leads to your answer. Okay, so at t is equal to 5, so we're going to look at g of 5. G of 5 is what is entering the plant, okay? So that's the rate at which things are entering the plant. So that's how we're going to tell if something's increasing or decreasing is by the first derivative. So we're pretty much given the first derivative. So we go to our table, we hit 5, so 98.141. Okay. Tons per hour. Now, what's going to be leaving the plant is going to be the processed gravel. So I'm going to call that L. And this is hard to recognize what this is because it's kind of embedded up here. So it says during the hours of operation, the plant processed the gravel at a rate of 100 tons per hour. So L of 5 is going to be 100. Okay, so 98.141 minus 100 gives you a negative 1.859 tons per hour. Okay, so is the amount of unprocessed gravel at the plant increasing or decreasing? So the unprocessed gravel is at a lower rate than this one, so it's going to be decreasing. At t is equal to 5. Yeah, that was a little tricky. Okay, part D, what is the maximum amount of unprocessed gravel at the plant during the hours of operation on the workday? Justify your answer. Okay, so I've been using this word accumulation function. Okay, so we know that the amount of gravel that arrives is going to be the integral of g of t, okay? And it's processed at a rate of 100. So that's my L of t, okay, what's leaving. And then I initially have 500 tons of gravel at the plant. Now, if I'm looking for a maximum or a minimum, I'm going to take the derivative of this, okay? So it's g of t minus 100. The derivative of 500 is going to be 0. Remember, whenever I take, sorry, this should be a t, not an 8. Same mistake again. Okay, so when you take a derivative of an integral, the integral goes away. So we're going to set this equal to 0. Okay, so we want to figure out at what time g of t is equal to 100. Okay, so we can use our zeros or we can use intersect, whatever you like to use. So I'm going between 0 and 8, so I need to make sure I change my window back. Okay, so I'm going to find that 0, second calc. Going to go above, below. And I get 4.9234. So that's going to be my critical point. Now, on an absolute max and an absolute min question, we have to consider the endpoints also. And I know that this is probably going to be a max because it goes from positive to negative. Okay, so let's consider our endpoints. A of 0. So A is equal to 0. This integral goes to 0 because the limits don't change, and so you're just left with 500. A of 4.9234. We'll deal with that in just a second, and then A of 8 we're going to deal with in just a second. So what I need to do is, to get these values, I'm going to have to integrate this portion of the function and then add the 500 to it. Okay, so that's minus 100. Okay, I already have that in y equals, and so I'm going to integrate math 9 vars y1 comma x comma 0 comma 4.9234. Okay, then I'm going to add the 500 to that because that's the initial amount. So I have 635.3761. And then I'm going to do with 8. Math 9 vars y1 comma x comma 0 comma 8. Okay, I get 25.551 plus 500. So at 525.551. Okay. So this is going to be your absolute max. Okay, so the point of this question is accumulation is rate in minus rate out plus how much you have initially at the beginning of time. I believe on your homework I put a question like this, so make sure we're paying attention to that. Okay, a particle moves along a straight line for t is equal to 0 to 5. Velocity is given by that function, and the position of the particle s of 0 is equal to 10. Okay, find all the values where the speed of the particle is 2. Remember, speed is equal to the absolute value of your velocity function. Okay, so what I'm going to do is I'm going to take my v of t in absolute values, and I'm going to set it equal to 2. So I'm going to put that in y equals. So negative 2 plus x squared plus 3x to the 6/5 power minus x cubed. Now, I'm doing absolute values, so I'm going to go and I'm going to insert math number absolute value, and I'm going to close my parentheses like that. And then I'm going to figure out where it's equal to 2, or so I can use my intersect, or I can move that 2 over. So I'm going to graph, and I'm going to have to change my window from 2 to 4. Okay, so window 2 to 4. Always pay attention to your window. So I got 1 and 2. So we do second calc 0. Above, below. So I get 3.126. 76, sorry. And then I'll find my second 0. .4734. Okay, part B says write an expression involving an integral that gives the position s of t. Use the expression to find the position of the particle at t is equal to 5. So to find position from velocity, we're going to integrate. Okay, in this case, they use s's. S and x are going to be the same thing, so no worries there. Okay, now when we go to integrate, we have to get rid of our absolute value. Okay, and we're going to get rid of that too. So make sure you have the original velocity function in there. Okay, so we're going to integrate that. Math 9, comma x, comma 0, comma 5. Add that extra parentheses in there. Okay, so you should get negative 19.20 7.3. We're looking for the position at t is equal to 5. Your initial position is going to be given as 10. So we're going to add that 10 to the other side, and you should get negative 9.207. Okay? Part C. It says find all the times where the particle changes direction between 0 and 5. So a particle changes direction when the velocity is equal to 0. Now the reason why I'm always writing this is because this gets you points. Okay? Even if you don't know how to do it, write that. Changes direction at v of t is equal to 0. So my velocity function's right there, and I need to change my window from 0 to 5. Okay, so we get a graph that looks like that. So it's going to cross here and here. So I'm going to use my zeros. And the first one's going to go from negative to positive. So we know it changes direction. So you should get 0.536. And then you're going to do the other one. Above, below, hit enter again. You get 3.3177. Okay, and then this one went from negative to positive, and this one went from positive to negative. Yep, and that's how we justify. Part D, is the speed of the particle increasing, decreasing at t is equal to 4? Justify your answer. Okay, so v of 4 and a of 4 is how we determine this. Okay, so v of 4, we're going to use our table because we've got our velocity function there. It's a negative 11.4758. Make sure we always go 3 decimal places, so we just clicked over on it. And then a, to get your acceleration, we're going to take the derivative. So we math 8 vars y1 comma x comma 4. Negative 22.2957. Okay. So since they have the same sign, speed is increasing. Okay. So we should be pretty good at these by now. Okay. Number 4. Okay, it says hot water is dripping through a coffee maker filling a large coffee cup. The amount of coffee in the cup is given by the table, and select value C of t. Okay, so part A, it says estimate C prime of 3.5. Okay, so we're going to locate 3.5. It's in between those 2 points up there. So we're going to do 12.8 minus 11.2 over 4 minus 3, and you should come out to be getting 1.6 ounces per minute. Okay, it's always your y unit over your x unit. Okay, that's it. B, is there a time between t is equal to 2 to 4 such that c prime of t is equal to 2? Okay, so this is going to be MVT, mean value theorem. Okay, it says that it's going to be continuous and differentiable, so we need to write that. Okay, so mean value theorem says that f prime of c, we're doing c prime of little c, okay, is equal to f of b minus f of a all over b minus a. So what I'm going to do is I'm going to do my average rate of change between 2 and 4. So we're going to do 12.8 minus 8.8 over 4 minus 2. So we get 4 divided by 2, which is equal to 2. So mean value theorem guarantees this to be true. Okay. Okay, this question, it says that we're going to, we want to interpret the value of 1/6 the integral of from 0 to 6. So anytime there's a fraction in front of this, we know that's going to be the average value. So average value of ounces of coffee from t is equal to 0 to t is equal to 6. Now it says I want to use a midpoint Riemann sum with 3 subintervals. Okay, so we haven't done a midpoint one over this over the course of these videos, so that's why I picked this one. So your midpoints. So it says we want to have 3 subintervals, like that. So each one of those is going to be 2. Now the midpoint are going to be these points right here. So that's what we're going to use for our y values. Okay? So we're going to do 1/6 times 2 times 5.3 plus 2 times 11.2 plus 2 times 13.8 divided by 6, and you should get 10.1 ounces. Okay, the amount of coffee in the cup is modeled by 16 minus 16e to the negative 4t. Use this model to find the rate at which the amount of coffee in the cup is changing at t is equal to 5. So we're looking for the derivative. So b prime of t. If you want to take the derivative by hand, this is easy enough to do by hand. So derivative of 16 is 0. Derivative of e is e to the u du. So 16 times a negative 0.4 comes out to be 6.4 e to the negative 0.4t. And then b prime of t would equal to 6. Sorry. We're evaluating it at 5. We're evaluating at 5, so 6.4 e to the negative 0.4 times 5. Okay, so this is 2/5. So 2/5 times 5 is 2. So my final answer is 6.4 e to the negative 2. Now, if you want to use this in the calculator, you could have, okay? Next question. Okay, so this one looks a little bit different. So number 5, it says find all the open, so you're given a graph, this is the derivative, and I want to interpret this. So it says that, you know, that these are going to be your critical points. Okay, this would be a max, this would be a min, and then your inflection points occur at the hills and valleys. Okay, so it's important that we make sure we know how to interpret a derivative graph. Okay, for part A, it says find all the intervals where, or it says, sorry, find where we have a local min. So we have a local min at x is equal to 1, 2, 3, 4, 5, 6. Okay, and we're going to say a local min occurs where f prime of x is equal to 0, so that's my critical point, and changes from negative to positive. Yep. And that's it. Part B. It says determine the absolute minimum value on the closed interval from 0 to 8. Justify your answer. Okay, so whenever we're dealing with absolute max and mins, we have to consider our critical points. So our critical points are going to be x is equal to 1, x is equal to 3, and x is equal to 5. Your endpoints are x is equal to 0 and x is equal to 8. Now the only ones that we need to plug in are going to be the ones where you're going to have a min, okay? So we're going to consider this one right here at x is equal to 6, 0, and 8. We don't need to consider where there's going to be a max. Okay? So the way we get the absolute max or min is by dealing with a y value. So we plug into the original. So to get our y value, we have to integrate. Okay? Now, we're given f of 8. So that's going to have to be our go-to point in all of this. Okay? So we're going to do the integral from 0 to 8 of f prime of x dx. So it says from 0 to 8, so this area is 2, 6, that's 8. 8 minus 3 is 5. 5 plus 7 is 12. Okay, is equal to f of 8 minus f of 0. Okay, f of 8 is given as 4. So that means that f of 0 is a negative 8. Okay, now we already have f of 8 is equal to 4, so we don't have to do any work for that. Now we need to integrate from 6 to 8 to figure out what the y value is right there. So f of 8 minus f of 6. Okay, the integral from 6 to 8 is 7. So you're given this area right here is 7. Wait. Why did I get 5.5? Hold up. 1, 2, 3, 4, 5, 6. Yeah, it should just be 7. I don't know why I wrote that. So f of 8. So f of 8 is 4. So when I solve this out, f of 6 is equal to a negative 3. So this is going to end up being your absolute min because it has the lowest y value. Part C doesn't really require any work. So on what intervals is the graph both concave down? So concave down means that you have negative slopes on your derivative graph. And I want to know where it's also increasing. Remember, this is your derivative graph. So increasing is positive y values. Okay, so it's going to be decreasing from here to here, and it has positive y values. So 0 to 1. It's increasing. It's decreasing from, looks like 3 to 4. And it has positive y values. Not going to be in this region because it's negative y values. And then it's increasing right here. So won't get any other answers than 0 to 1 and 3 to 4. Part D. Okay, it says let the function g be defined by g of x is equal to f of x cubed. Okay, f of x quantity cubed. And I want to find the slope of the tangent line of that. Okay, so g of x is equal to f of x cubed. So if I was to take the derivative of this and do power rule, reduce the exponent by 1, and then I have to chain rule the inside. So I'm evaluating it at 3. Okay, f of 3 is given as a negative 5/2. So we get 3 times a negative 5/2 squared. And f prime of 3 is going to be 4. Because you read your y value gives you your derivative. Okay? Square all this stuff out. Negative 5 squared is 25 over 4. This will end up canceling right here. 4 and 4 will cancel, so you get 75. So that was a little bit different question. I want to save that one to work with y'all. Okay. Next one. Solids revolution. So your cosine graph is going to start at the y-axis, and it's going to go down like that. So g of x is going to be 4 cosine of pi over 4x. This one is going to be your f of x on bottom. It's going to be 2x squared minus 6x plus 4. Now I believe that this one is going to be a non-calculator question. Okay, for part A, it says find the area of R. So we're going to integrate from 0 to 2, and you're going to do your top curve minus bottom curve. Okay. So we integrate this. We're going to have u sub right here. U is equal to pi over 4x. Your du is pi over 4 dx. I don't have the pi over 4, so I'm going to multiply by the reciprocal to get rid of it. So this becomes 16 over pi. Integral of cosine is sine. Like that. And then I'm going to integrate this portion. So 2/3 x cubed minus 3x squared plus 4x. And I'm going to evaluate that from 0 to 2. Okay, so plugging in to this portion right here. 16 over pi sine of 2 times pi over 4 is pi over 2. Sine of pi over 2 is 1. Sine of 0 is 0. Okay, now we're going to plug in our 2. 2 cubes 8, so this comes out to be 16/3. 2 squared is 4. 4 times 3 is 12. Plus 8. Like that. And then, so combining my like terms, so this is 16/3 minus 4, so this is 4/3 around the world. And so we get 16 over pi minus 4/3 is my area. Okay, part B, it says write but do not evaluate an expression, and I'm going to revolve it about the line y is equal to 4. So y is equal to 4 is up here. We draw our ladder. Okay, and we got to do r big and r little because we have white space right there. So r big is going to be 4 minus 2x squared minus 6x plus 4. Important that you use parentheses around that whole entire thing. R little is 4 minus the cosine Okay, so our volume is going to be pi times the integral from 0 to 2 of 4 minus 2x squared minus 6x plus 4 squared minus r little squared. 4 minus 4 cosine of pi over 4x squared dx. Sorry, I ran out of room. Okay, part B. It says let R be the base of the solid. We're doing cross sections, and it's going to be a square. Okay, so volume by cross sections is going to go from 0 to 2, and it's going to be top curve minus bottom curve squared. Okay, there's no pi in this. So your top curve is 4 cosine of pi over 4x minus 2x squared minus 6x plus 4, parentheses like that. So we're not evaluating it, just setting them up. So we should be pretty good at these by now. Okay, differential equation 1. Okay, so AB, I want you to do part A and part C. I don't want you to do part B because it's going to be Euler's method. Okay, so you don't need to know Euler's method. Okay, part A says find the limit as x goes to 0 of this. Okay, so f of 0 plus 1 over sine of 0. So if I was to plug in f of 0, it's a negative 1. Sine of 0 is 0. So negative 1 plus 1 is 0. So when we got 0 over 0, we have to use L'Hopital's rule. So L'Hopital's rule is going to be the derivative of the top of the derivative of the bottom. So the derivative of f of x is f prime of x. Derivative of 1 is 0. And derivative of sine of x is cosine of x. Okay, so we're going to evaluate our limit now. So we're going to plug in our 0. And we're going to plug in, so cosine of 0 is 1. Now, how do I find my derivative? Well, I'm given dy dx. Okay? So I'm going to plug in a 0 for x. So 0 plus 2 is 2. And negative 1 squared is 1. So 2 times 1 gives you 2. Okay, part B. This is for BC. So I need y'all to make sure y'all remember how to do L'Hopital's rule. That's why I wanted you to do this question. Okay, so Euler's method, y1 is equal to y naught plus h times f naught. Okay, we're starting x is equal to 0, and I want to use 2 steps of equal size to get to 1/2. So that means my h is going to be 0.25. If I plug my original function into the my derivative, you should get 2, just like we just did. So negative 1 plus 0.5 is a negative 0.5. So that's going to leave us at the point 0.25, negative 0.5. And then we're going to repeat the process. y2 is equal to y1 plus h times f1. Your y1's a negative 0.5. Your h is still 0.25. And to get your derivative, we're going to plug into this over here. So 2 times x, so that's 0.5 plus 2 is 3/2. Okay, so 3/2 times 1/4. Wait, hold up. Let's go ahead and plug in. Let's not skip steps. Okay, so negative 0.5 squared times 2 times 0.25 plus 2. Okay, so 0.5 squared is going to be 1/4. Okay, so we get 1/2 right here. So this is 5/2. Okay, not 3/2. Okay, so that comes out to be 5/8. So this is 1/4 times 5/8. So it's 5/32. Get a common denominator. And and you should get negative 11 over 32. This is going to be 16 over 32. Okay, so that's my answer. I don't know if that's a non-calculator question or calculator is easy enough to do by hand. Make sure when you add and subtract fractions, you have to have a common denominator. Okay, so it says find the particular solution. So this is your differential equation stuff. So dy dx is equal to y squared 2x plus 2. Okay, so we're going to get all our y terms on one side and all our x terms on the other side, like that. We're going to integrate both sides. The integral of this, we're going to rewrite this as y to the negative 2. So we're going to add 1 to the exponent, divide by the new exponent. So it's negative 1 over y, which is negative y to the negative 1. X squared plus 2x plus c. Okay, I'm going to use my initial condition. It says f of 0 is equal to a negative 1. So c comes out to be 1. So once I find my c, I take it and I plug it back in. Okay, so to solve for y, we're going to divide by negative. So we're going to change all the signs. And to solve for y, when it's on the bottom, we're going to reciprocate everything. Minus 1. Crap, I didn't change all the signs. Sorry, plus 1, minus 1, to minus 1. Okay, so that's my answer. Okay, AB, you're done. BC, we got a Taylor series. Okay. So a function has derivatives of all orders. Let P of n denote the nth degree Taylor polynomial for f about x is equal to 0. So it's actually a Maclaurin series. It is known that f of 0 is equal to a negative 4 and that P1 of 1/2 is equal to a negative 3. Show that f prime of 0 is equal to 2. Okay, so what does this P1 mean? Is we're going to write the first degree Taylor polynomial. So your first degree Taylor polynomial is you write the first term, which is negative 4, plus f prime of 0 over 1 factorial times x. So we get this. Now, it is known that negative 3 is your y value, and your x value is 1/2. So if I go to solve this, if I add the 4 to this side, I get a 1. So I get f prime of 0 is equal to 2. Part B, it says that it is known that the second derivative is equal to negative 2/3 and the third derivative is equal to 1/3. Find the third degree Taylor polynomial. So P3x is negative 4 plus 2x, because we already found that, over 1 factorial, which is 1. Your second derivative is negative 2/3 over 2 factorial times x squared. And your third derivative is 1/3 over 3 factorial x cubed. Okay? If you want to simplify it, be my guest. It's easy enough to simplify. Negative 4 plus 2x. 2 factorial is 2. So this comes out to be 1/3 x squared. 3 factorial is 6. So this is 1/18 x cubed. Okay, it says let h be the function that is given by the first derivative f of 2x. It is known that h of 0 is equal to 7. Find the third degree Taylor polynomial for h. Okay, there's two ways to do this. I suggest you do it the way I'm doing. I think it made more sense to me. Okay. So I know that I don't know what h of x is. Okay. But I do know what the first derivative is. If I take my second derivative, I get 2 times f of 2 of x, right? You get your chain rule. And then my third derivative, because any third degree, is going to be 4 times f of 2x. Sorry, f prime. I forget my primes. Okay, so going through the derivatives real quick. H prime of x is equal to f of 2x. When I take the derivative of this, I take the derivative, you get f prime of 2x, then you chain rule it, you get the 2. Take the derivative again, you get f double prime of 2x. I have to chain rule it again, so that's where I get the 4 from, because 2 times 2. Okay, so h of 0 is given to me as 7. H prime of 0 is f of 0. So I get f of 0 from up here is a negative 4. H double prime of 0 is 2 times f prime of 0. F prime of 0 is 2. And h triple prime of 0 is 4 times f double prime of 0. And f double prime of 0 is negative 2/3. Okay, so that's 4. That's negative 8/3. Okay, so when I go to write my Taylor polynomial for h of x, like the first term, minus 4x plus 4 over 2 factorial x squared minus 8/3 over 3 factorial x cubed. If you want to simplify this out, 2 factorial is 2. 3 factorial is 6. So that's it. Hopefully this was helpful to you guys. Keep working on this Taylor series a lot. And if you need anything, feel free to reach out. Thanks. Have a good day.